we're going to create a simple example that passes data between a PLC and a command HMI. So to do that, we're going to use an ACE 1430 in this example, but the concept should apply to any of the ACE or branch PLCs that have RS-232 ports on them. Do an auto setup, and we're going to use the default parameters here, 9600, and no parity. So the idea here is we're going to use an input switch on the PLC. We're going to pass that data to the HMI. We're going to have a button on the HMI that passes data back to the PLC, and we're going to use a timer that we'll set up on the PLC. We'll pass that up to the HMI, display that there, and we'll have a numeric entry on the HMI that we pass that data back to the PLC. So we'll kind of see bits in both direction and then non-bits in both direction. So we'll do a couple things to get that started. We'll create a timer called my timer, and then the next thing we need to do is let's see here. We'll use a copy instruction, and all we're going to do here is we're wanting to observe some of the data live. So when we have it, we'll call that, we'll float. When we have this copy on the screen, we put in debug mode, we'll be able to see the data that's actually inside of here. So all we're going to care about is the left side parameter. We're going to put it into some dummy variable that we don't care about at all. All the data will go into the same dummy variable. There we go. And we just do that so that when we go into debug mode, yeah, we can look at the left side here and we can see what's going on inside the PLC. It'll be a quick check for us. Okay, so the other thing we need to do is we need to set up Modbus addresses. So we'll do the input bit, that's input to the PLC. We'll do an output bit, and let's make that one remote writable so the HMI is allowed to write to it. And you can see the remote writability. And right here, this column, the command HMI column, that's going to be key. That gives us our addresses that we're going to use for the command HMI. And we will we'll send it our timer, which is an I32, and we'll get back from it the from HMI, which is going to be a floating point number. And you can see their respective addresses there. Okay, so we now program this, and we'll tell it to run, and we'll switch over here. Okay, so I need to create a new project, and we'll call it a com test. And if you look at the back of your PLC, I'm going to be using the 4.3-inch one that we offer. Do that, and then you want Modbus as the protocol. The other defaults are fine. Pick your background for your main screen. I'm going to just call it main, and we'll finish there. Okay, so we'll get our bits working first. So we want a bit lamp, and we'll quick reference the Modbus sheet again. Okay, so the bit that's coming from the PLC, that's address 0x0. So when we do the bit lamp, I like to make the lamps circle size so I can differentiate them from the from buttons. And 0x0 is the address to use, and we do OK. So that's our lamp. That's now we got a bit switch, so we're going to turn it on or off, and I'll do alternate, and that was 0x1. And I do want to monitor that data, and I want it to be the same address. Okay, so that will cause the value to change, and we'll see that on the PLC. And then we've got two more things. We want to display a number coming from the PLC. That's going to be the timer. And we'll go ahead and look at that again. And you'll see that it's an I32 for one thing, and it's an address 4x0. So that's what we'll use. We'll use we need to do a 32-bit signed integer, I32, and we'll use 4x0, and that'll be fine. Sometimes I just prefer numeric stuff to just be transparent. If it's a numeric display, I don't want it to look like it's something that can be pressed. Okay, and we want to use a numerical input. That's going to be the floating point we were talking about. We'll select floating point, and then it's 4x2 in this case. And style-wise, I prefer to make those white on the center. And that's fine. Okay, so we've got that. We've got all 4 pieces of data. So let's save it, download it. I can download it to my screen, which I don't have plugged in. 1 second while I pause it. Okay, I've got it plugged in now. It'll give you this nice error if you're not plugged in. You can hear it. You push this, it'll restart the touchscreen. Okay, I'll close this. I can jump over here. It's booting back up right now. And we'll go into the debug mode, and we'll go to the numerical view. Okay, so I'm going to use the toggle switch on the PLC, and you can see it turns this on here, and I can just relay to you that it is coming on. The signal, which is the circle that we have here, it is showing an on my screen. That's less interesting to view than when I'm going to push the button, the rectangle here. I'm going to push this, and it's going to cause it to go on, and we look at it here. I'm going to push it. It's this value right here. When I push it, it goes on. Push it again, it goes off. So you can see that's coming from the HMI to the PLC. Okay, so if I look at this right here, I'm getting the timer reading, and sure enough, it is giving me the live reading of this exact number. And I'm going to go ahead and I'm going to, on the floating point variable, the numeric entry, numeric input, I'm going to go ahead and type something in. I'll do 1, 2, 3, and I'll hit enter. And it's not working at the moment, and I'm sure it's because I set something up wrong. Let's see what we got here. Floating point, address 2. I bet you I gave the wrong address there. Oh, the issue is I didn't make it writable. Okay, so we're going to make it writable. Okay, we'll do this again. And now I will. Okay, we can see the values inside it. I'll do 1, 2, 3 again. I can hit enter, and there you go. You can see 1, 2, 3 there. If I were to go 4, 5, 6, enter, you'd see it. Well, if I actually typed it right, 4, 5, 6, you'd see it becomes 4, 5, 6 here. So we've got two-way communication, and we'll post the sample code for this project online.